All right, so we're now moving on to our next section, which is going to be our third topic that we're covering here. And we're going to be solving equations with variables on both sides. All right, so that's what we're looking to do next. So our learning objectives at the end of this video, what you must be able to know how to do is you should be able to know how to solve equations with variables on both sides of the equation. Right, so when I have 3x plus 2 is equal to 5x minus 1, how do we go about solving that? Where we have variables on both sides of the equation. You'll also know how to solve equations where you must simplify first before solving. So we've already done some of these questions where maybe it'd be parentheses, so 3 times x plus 2 minus 4x is equal to 8, something like that, where we must simplify first before we can go to solve. And then what you're going to learn today as well is there are going to be some special cases that you guys will learn. So students will know when an equation has no solutions or when it has infinitely many. All right, so by the end of the video, you should come back to this and be like, okay, do I have some sort of understanding for this? Remember, you don't need to master it by the end of the video, but have some sort of understanding so that way you can answer some questions about this. All right, so before we get into any of the questions that we're trying to make sure we learn today, I just want to go through again a question that we all should be able to answer. And just kind of talk about what our goals are when we're actually trying to solve these equations. So when we're solving our equation, what we're trying to do is we're trying to actually isolate our variable. So what that means is we're actually trying to get our variable on one side of the equation. So if we have an equal sign, we're just trying to get our variable all alone. So that means nothing being multiplied, added, just the variable with the coefficient of 1 in front of it. So we're trying to get our variable all by itself on one side of the equation, and we're trying to set our constants to the other side of the equation. And that way it allows for us to go ahead and answer this question. So that's our goal, is always to isolate our variable, get our variable all by itself with a coefficient of 1, and move all of the constants to the other side of the equation as well. So we get our variable is equal to some number, and that will then tell us what the answer is. So when we're going through and doing this first problem, let me just move this over here so I can go ahead and solve. Remember, we ask ourselves, what is being done to our variable? Well, we have multiplication and we have addition. And remember, we're doing our PEMDAS in reverse, so we actually will need to get rid of this addition first. So we'll subtract 2 from both sides. That's our inverse operation. So then I get 10x is equal to 30. And then to get rid of this multiplication of 10, we will then divide each side by 10, and we get x is equal to 3. So you see, when we're answering and solving for an equation, we're isolating that variable all by itself on one side of the equation with a coefficient of 1. So it's important that we know this because it's going to help us when we're trying to figure out, well, what do we do when we have variables on both sides of our equation? All right, so let's go ahead and move on to the next question. See now, so when we look at this problem, I see 6x is equal to 5x plus 22. So I have variables on both sides of my equation. And remember, our goal is to have our variable on one side of the equation and it's set equal to a constant. Well, if I look here, I only have one constant. My only constant is 22, and my 22 is on the right-hand side of my equation. So that means I need to move all of the variables that are on that side of the equation to the other side. So I need to move this to the other side of the equation. And remember, when we're moving something on the opposite side of the equation, we need to use the inverse operations. So in this case, before we try to solve anything, we need to first simplify and try to get down to just that one variable x, meaning that we can't have multiple x's unless they have different powers, but we're not going to do that till later on in the year. But for now, we just need to move all of our variables to one side of the equation and combine all of our like terms to get it down to just that one variable. So if I want to move a positive 5x to the other side of the equation, I need to subtract it, because what we can think about now is if I want to isolate this constant all by itself, well, I could be asking myself then what is being done to the constant? And what's being done to the constant here is we're adding 5x to it. So if I want to get rid of that 5x, and that way I can isolate the constant all by itself on the side, well, then I can move 5x to both sides of the equation. And in order for me to move anything to the other side of that equal sign, I must take its inverse operation. So I'm actually subtracting 5x here. And 5x minus 5x is going to give me 0x, so they then cancel each other out. And 6x minus 5x is x, so x is then equal to 0 plus 22, which we don't need to do that because we know 0 plus any number is just a number that we have, so x is then equal to 22. So our goal here is to move all of our variables to one side of the equation. And we do that through addition and subtraction. When we're moving an entire term, not just dividing, not just multiplying, we're moving the entire term. And the entire term in this case is 5x. In order to move the entire term, we will then have to add or subtract in order to move it to the other side of the equation. All right, before we move on to another example that I have with variables on both sides, I just want to go through again what we would need to do sometimes when we have a parentheses or when we have multiple terms on one side of our equation. Remember, we always want to simplify as much as we can. So when I see these parentheses are telling me that I'm doing 21 times whatever's on the inside of that. So I can distribute this 21 in to clear out those parentheses. So 21 times 2 gives me 42, and 21 times negative x is negative 21x, plus 12x is equal to 44. And now, when we're doing this, we need to simplify everything that we can. So I see here, these are both x's. So that means that they are like terms. They have the same power and the same variable. So I can go ahead and add those together. And remember, when we are combining like terms, we're just doing the numbers in front are what we're adding together. So we're just essentially doing negative 21 plus 12x, which would then I know is going to be equal to negative 9. So it's 42 minus 9x is equal to 44. Now, you could have just gone straight from this step down to this step. You did not need to show me what's in green, because if you know how to combine like terms, you can do that in your head. All right, now I need to isolate my variable, so I'm asking myself what is being done to it. So I have addition, because it's positive 42 here, and I have multiplication. So I'm going to go ahead and get rid of my addition first, because remember, we're doing a PEMDAS in reverse. So my addition, inverse of addition is subtraction, so I'll subtract 42 from both sides. These then cancel, so now I'm left with negative 9x is equal to 2. And then I'm going to get rid of my multiplication through division, so I'm going to divide each side by negative 9. And then I get that x is equal to negative 2 over 9. You do not need to write that as a decimal. If you wanted to, you can, but just leave it as a fraction. It can't be reduced, so that will then be our final answer. Right, now for this problem, for question number 4, we have a little bit of everything, because I see I have variables on both sides of my equation, so I have x's here, and I see I have parentheses on both sides. So what I need to do first is simplify everything I can. So I'm going to distribute this negative 2 in. Negative 2 times x gives me negative 2x. Negative 2 times negative 5 gives me positive 10. And then it's going to be equal to, and I'm going to distribute this 6 in to both sides as well. So 6 times 2 gives me 12. And 6 times negative 0.5, which is the same as 6 times negative 1/2, is going to give me negative 3. So it'll be minus 3x. All right, now, same thing as we did before. We look and see, okay, I have variables on both sides of the equation. And honestly, it doesn't matter which side you move it to. You can always move your variables to the left-hand side if you want. You can always try to see, okay, which way will make my variable positive, so I don't need to worry about a negative number. You're always going to see me move my variables to the left-hand side. It's just the way I've always solved them. So when I see my variables on both sides here, I'm going to go ahead and take this minus 3x. I'm going to move it to the other side of the equation. And remember, to move the entire term, we're always going to be adding or subtracting. And since this is a minus 3x, the inverse of subtraction is going to be addition. So I'm going to add 3x to both sides. Negative 3x plus 3x cancels. So minus 2x plus 3x will give me an x. So now I'm left with x plus 10 is equal to 12. Once we do this, this is a problem that you all should be able to do. We're now trying to identify, okay, what is being done to my variable? Just addition in this part is being done. And I know the inverse of addition is subtraction. So I'm going to subtract 10 from both sides and get x is equal to 2. And that would be my final answer. I can go ahead and plug this in if I really want to check to make sure I did this correctly. All right, so these are the last 2 questions now that we're going to go through. Now, these questions are special cases. So that's why I have them next to each other at the same time. And I'm going to first solve them and show you what the answer looks like. And then we're going to talk about what this answer is actually telling us. All right, so for this first problem, I see I have my variables on both sides. So once again, I like to move my variables to the left-hand side. So I'm going to move this minus 4x to the other side. So in order to do that, remember, when we're moving an entire term, we must add or subtract. So I'm going to go ahead and add this 4x since it's being subtracted. That's going to cancel out. I'm going to add 4x to the left-hand side as well. Well, what do you notice? In both of these cases, it's going to completely cancel out my x's, and now I get 3 is equal to negative 7. All right, we're going to pause there for a second. We're going to go ahead and move an answer into number 6, and then we're going to talk about what these answers are telling us and what the difference between them is. All right, so when I go to do this question number 6, I see my parentheses. So once again, I'm going to distribute this 4 in so I can simplify everything first. So 6x plus 4, well, 4 times 3 will give me 12. So if we do 4 times 3 over 2, 4 times 3 gives me 12. 12 divided by 2 is equal to 6. So it's 6x plus 1. Once again, I see I have variables on both sides of my equation, so I'm going to move my variable to the left-hand side just because that's what I like to do. You can move it to the right, it doesn't really matter. But to move the entire term, I'm either going to add or subtract, so since it's positive, I'm going to subtract. This 4 being distributed into this 1 should have given me a 6x plus 4. Right, so now I'm going to subtract the 6x from both sides. Same thing, 6x minus 6x gives me 0x, so it completely cancels out. And 6x minus 6x gives me 0x, and it completely cancels out there as well. So now I'm left with 4 is equal to 4. Right, so there are cases where our variable is going to completely eliminate. And we're going to get a statement that is either true or false. And when we look at this, 3 is equal to negative 7, that is a false statement. Right, that is not true. And we see here, 4 is equal to 4. That is a true statement. So when we get our variables completely eliminated, if we get a false statement, so if we get two numbers that don't equal each other, like 3 can never equal negative 7, that means that there is no solution. That no matter what we plug in for x, we will never, ever, ever be able to solve this or get a true statement. Because no matter what, essentially, if you think about this, our x's are exactly the same. So if I'm plugging in the exact same number, so if I plug in 1 for x, let me just show, let's just say x is equal to 1. When we plug this in, we'll get 3 minus 4 is equal to negative 7 minus 4. So since our x's have the exact same coefficient, these numbers will always be the same. However, since 3 and negative 7 don't equal, we'll never be able to have a true statement. Because 3 minus 4 is negative 1, and negative 7 minus 4 is negative 11. So you see, we're always going to have a different number on both sides of our equation because the minus 4x is the same on both sides, but then on one side we're subtracting 7 from it, and the other side we're adding 3 to it. So no matter what we plug in for x, we're always going to be adding, subtracting those different numbers, meaning it will never be true. So if it's a false statement, it's no solution. If it's a true statement, then it's infinitely many. Solutions. And that actually means that no matter what we plug in for x, it's always going to work. Because if you notice, here we have 6x on both sides of the equation, and no matter what I plug in for x, in both cases, they're being added by 4. So if we say x is equal to 2, well, in both of these cases on the right-hand side, we're going to do 6 times 2, which gives me 12. And then we're going to be adding 4 to that 12 on both sides as well. So no matter what we plug in for x, it's always going to give us a true statement, which means every single number that we plug in for x is going to work. So this is something that you have to make sure you understand, that if we get a false statement and our variables completely cancel out, then it's no solution. It means nothing will ever work. And if we get a true statement and our variables completely cancel out, that means infinitely many solutions. All right, that is it for this video.